Typically on this channel, we've talked about a lot of OEM style engines like the 2JZ, 1UZ, the LS series, Coyote, Voodoo, etc. We've talked about pretty much exclusively OEM engines, but today we're gonna look at something really cool, which is what happens when a mechanical engineer gets bored and decides to smash two Honda K24s together to make one 5-liter V8. And this isn't just some CAD project that'll never see the light of day. This entire project is designed to be a real-world engine, hopefully by the end of 2021, and eventually be an engine that you or I could purchase and drop into our project cars. Let's get into it. Right off the bat, I want to say a big thank you to Craig Williams. He's the madman behind this project. He's a mechanical engineer that's been doing all the work, and this has been about a 5-year project for him. Go follow him on Instagram at Neutron Engines, where he regularly posts updates and answers questions about this engine and design changes that he makes. Before we get into the interview with Craig, I'd like to cover some basics on this project so you can get an idea of just how insane it is, but also how well designed it is. As you guessed from the title, this is a Honda K24 V8 project. So it's basically two K24s that are stuck together in a V configuration to create a V8 engine. Obviously, you can't just bolt two engine blocks together. So the entire project is designed around a CNC machine custom V8 block. But in the future, Craig did mention that he wants to be able to cast this engine to really bring the production cost down so it's really affordable for average enthusiasts. What I think is the most interesting design feature of this engine is the fact that it uses two identical cylinder heads. And what I mean by this is that it has two cylinder heads which are completely identical, but in order to do that, there has to be a timing chain on both sides of the block. So that's exactly what Craig did. There's a timing system on both the front and the rear of the block. Now, by doing this, you can avoid using custom cylinder heads, which really brings the cost down significantly and makes it much more affordable. Although it is kind of a funky design, it's actually not that far-fetched because it's something that you would see on a BMW B58, for example, or other various Audi engines, which also have a timing system on the rear of the motor. Okay, that's enough of me talking because I'm just some guy on YouTube. Let's get into the interview with Craig so you can really hear about this engine and the design choices that he made. So what made you want to slap two K24s together? Where did this idea come from?
If I'm being 100% like totally and completely honest, it's because I was a little bored at my day job and I wanted an engineering challenge. And I love automotive, but I didn't work in automotive. So I was like, hey, you know what? I want to see what I can do. And this is the coolest thing in the entire world. I want to try and design an engine and just see if I can. So it started off as, let's just see if I can. And then it became, okay, I'm working on this, to then, holy crap, I'm doing this. And it kind of evolved.
How long have you been working on this project for?
About 5 years, but the last two are what have really taken off. I was diagnosed with a severe lung condition, and I have to spend a lot of time doing breathing treatments. And if you're stuck at your desk for 2 hours a day, might as well make it productive. That's when it became, okay, let's do this and fully commit.
And as far as I understand with the design, you're basically just using OEM K24 heads that are reversed. So you've got one facing one way, one going the other. So you basically have a timing chain on both sides. Have you put any thought about how you're going to mount a transmission, if that's going to be an issue, having a timing chain and a timing chain cover on both sides?
Yes. So it'll be kind of like a few different Audi engines and even the new Supra engine, the BMW. You have an entire transmission back plate that can come off, and the timing chain tensioner is actually above the transmission, so it's open and accessible up above that.
I already understand the reason why you went exhaust manifolds in the center of the V rather than on the sides, but could you just go ahead and explain it?
So I had already designed the block, and I had designed the oil return passages, and I had designed like all this stuff, and then I went to put on timing chain tensioner and figure out the oil galleries for that. And it ends up right in the middle of the block to girdle part line and really close to the main studs. So the oil gallery would have to be this crazy, like, noodle complex to get over there. And then being in that location, the screws like end up being really weird, and it just wouldn't. Maybe I could have made it work. It would have been a flawed design. It would have been problematic and had issues, and it would have also increased the overall width of the engine. Because on the K-Series, you don't notice that the timing chain tensioner is like out in the middle off to the side. But on a V8, it would be down low and in the off to the side, overall increasing the overall width of my package. Versus the Hot V, nice in the middle, in the center, and right next to the oil gallery, like it is on the stock K-Series.
That's really interesting. It's really smart that you did it that way.
I nearly quit the project during that time. I was like, I am so far in, I've spent so much money doing this. I got to figure it out. And I remembered, I think it was 2006, I went to Barrett Jackson, and there was a car there. I want to say it was a Ford Falcon, but it had this very special V8 that was really rare. It was from IndyCar that Ford had made, and had the exhaust in the center. And I saw that, and I remember thinking about that, and then I was like, you know, wait, there's actually been a couple of race cars that had this, and then learning about AMGs and BMWs that had it, and it all became far more doable and realistic. I was like, okay, this isn't that crazy. It's just a little different.
And as far as the cylinder block, is that going to be a custom CNC machined piece? Or I guess what was your plan with the cylinder block?
So my intention is that it'll be, the top half will be 60-61, and it'll be CNC machined. And then the bottom half will probably be 70-75. Sorry, most people don't care. A higher, even higher grade of aluminum. And it'll be machined and billet. The first few engines are going to be pretty expensive. But if I can work out all the kinks and make sure that, yes, I have a running, reliable, and as good of an engine as I think it will be and can be, and I don't have any issues, then I'll switch it over to a casting, and that's when I hope it'll be more mass market and more financially viable to everyone else.
And then the cylinder heads, this project is just going to be using OEM K24 or K28 cylinder heads?
So I'm partnered with Crayon 2 Racing, and they'll be providing the cylinder heads. The specs for those ones are their winner circle cylinder heads, but this works with all K24, K20 cylinder heads. And if somebody wanted to, they could use some other manufacturer of CNC cylinder heads if they'd like.
For the rotating assembly, is that all going to be aftermarket? Obviously the crankshaft is because, well, obvious reasons. But what about everything else?
So the timing chain for the front forward-facing cylinder head, all of that is stock. Every bit of it is stock you can use. Well, not the timing chain gear piece. That one's actually like trimmed down from the stock one, but essentially stock. The rear-facing head, all of that is custom, and it's a custom piece. And stock pistons will be able to be run on my current engine. My all-extreme, all-motor, I'm using custom pistons that are a lot lighter and a custom length connecting rod length to reduce my second-order vibration. But I don't think that's what most people will want or do. So a steel set of custom rods will be available that are much cheaper than the titanium versions that I'm currently running with, and so you can use stock pistons. You'll have to use custom connecting rods, and then the custom crank, and then the custom rear timing system. It uses a stock tensioner, but the two timing chain guides and rear gear are custom to my engine.
The one that you are building specifically as, I guess, this first engine or your more extreme engine, what kind of power are you aiming to achieve?
It started off with I just want to beat the Ferrari 458 Speciale engine because that's rated the #1 best naturally aspirated Ferrari V8 ever made, and I want to make more horsepower than that. And then it became, well, I can actually go a lot higher than that, and now we can go pretty high. So I don't have a specific number I'm shooting for. I have a certain RPM I'm trying to hit. I want to hit at least 10,000. I'd be pretty disappointed at only 9.5. But I want to, based on my math, I should hit 10,000, and I would like to hit close to 750 to 800 horsepower, if not more. This is closer to a drag spec all-motor K24. I don't have increased stroke, but I am at a full bore of 90 millimeters. Should be doable.
Yeah, well, I mean, I guess there's a lot of K24s that are, making like 300 wheel horsepower naturally aspirated. So I assume what you're doing is definitely capable of making that kind of power when configured, pretty much like a full-on drag racing engine.
I'm not going drag racing with my engine, but I want it to be capable. Like it has like piston oil squirters and stuff like that. So it should be a street-driven capable engine. But I just want it to be able to rev to the moon and be an all-motor, because that's what I like. I think I could hit crazy numbers boosted, and that'll be my second engine. But you can do that with, a regular K series, or you can do that with a 4G63 or an LS. And I think with how far turbos have advanced in the last couple of years, crazy high numbers out of that doesn't mean as much. The crazy high numbers out of a naturally aspirated engine that's making more horsepower per liter than any Ferrari naturally aspirated V8 ever made in any of their production cars. Yeah, I think that might be something that's special.
Yes, I definitely agree. Do you have a target time frame for this project to come to fruition and for fire the engine up for the first time? Do you have a specific time frame that you're going for this, or is it just kind of building it as you go, using your time as you can?
So I have parts already ordered. I have the pistons already ordered. I have the connecting rods. I asked them to make one adjustment to the connecting rods, so that should be ordered either on Monday or Tuesday. And the crankshaft is ordered as well. These are long lead time parts, 10 to 12 weeks. So I have 10 to 12 weeks to finish up the block and make sure that I am 100% confident that I like everything and the way it is, and that I have it all correct. And I would like to start running my first test, because even before I fire it up the first time, I need to just dry turn it over with the dry sump and make sure that all of the oil passages are producing the correct amount of oil and that I'm not getting starvation at a particular point. I've run simulations, but simulations are only as good as the quality of the person running those simulations. And if you haven't made a mistake, so I have to do those sort of steps first. I need to spin up the motor and make sure with all of its parts, make sure it's balanced, check timing, do a couple of those things. So I would like to start it up, if I was being ambitious, May. If I think it's like more realistic, I think it's closer to October as like hey, this is it. The rotating assembly is already all ordered, and my buddy has a 4th axis CNC large enough to run my block, and we meet regularly to discuss, okay, hey, we should change this to make it more manufacturable. So I'm doing everything, and so hopefully in the next couple of months, we'll see.
Basically, you said October potentially as a more realistic target. I think anything inside of like 3 years from now, what you're doing is very ambitious. So, just within 3 years from now, that's a very quick time frame for what you're doing.
You guys are seeing like all of my old like pictures and screenshots. I haven't shared hardly like none of the rotating assembly that you guys have seen on Instagram and stuff like that are representative of the current stuff. I just haven't shared it. Some of it I don't want to because there's people that will try and copy it, steal it, and so I'll probably keep some of those images and just say, you know, this is what it was when I was working on it a year ago.
Awesome. I think I have everything I need. Is there anything else you wanted to add?
I think I'd like to just thank a couple of the people that I cold contacted and they just responded to me about this project. I contacted Darton and was like, hey, I need more details about your mid-sleeve and to know, hey, will this work? This is my idea. Is this a good idea? Is this a bad idea? Them just responding and helping out with this project has been huge. Also, getting some of that help and support has been really helpful from King Bearing as well. Them sharing actual engineering drawings with me of, hey, this bearing is manufactured this way. These are the tolerances that we're hitting. So you need to design your block around that. Like my engine does not have stock bearings at all. If you were to use a stock K24, K20 main bearing and connecting rod, it might work for an all motor, but as soon as you went into boost, it would snap the crank, like 100%. So I'm using actually a Lamborghini V10 main bearing, and then a totally different connecting rod bearing as well to offset and make up for how tiny the Honda bearings are and how little rod bearing to main bearing overlap. That overlap, just to give you an idea, is only 18 millimeters squared of area. But with my new connecting rod journals and main bearing journals, I'm at 375 millimeters of squared area. So drastic strength increase. So my engine should be able to handle boost, be able to handle that without an issue. And that's something I'm really proud of. And I'm really grateful to Arrow, who helped point out some of those things. And we're like, hey, yeah, your simulations say this, but if you want this to work in other applications, we should consider, you know, something else. So Arrow, King, Crayon 2 Racing for the cylinder heads, and Dart are the big names that have been helpful throughout this project. And Fusion 360, that's the CAD program I've used for most of this project. I've used SolidWorks as well, but Fusion 360 is pretty much all of this program that I've used for this project. We're finally at a point where this is now time to start cutting metal and seeing if this will actually work. So see if I make a 40 grand engine block coffee table or if I'm actually successful. But, you know, with a few tries, I hope that I can bring something to the market that is compelling, different, and unique.
Alright, I hope you guys enjoyed the video. If you did, please smash the thumbs up button because it really helps me out. Go follow Craig on Instagram at Neutron Engines. Again, this is where he posts regular updates on the project, answers questions, and a lot more. So really be sure to go follow him. He's going to be able to answer any extra questions that you have. Be sure to also check out the other videos on the channel, get subscribed, smash the thumbs up button, and I'll see you guys in the next one.